in problem number 39 from our textbook, silver bromide, which breaks up into silver ions and bromide ions, its KSP is going to be the concentration of silver times the concentration of bromide. There are no exponents because there were no coefficients. And we're told that this equals 5 times 10 to the minus 13. So now we're finding the molar solubility. In part A, this is just another molar solubility problem. And we can tell that since these two must be the same, that we can put x in place of each one. So 5 times 10 to the minus 13 is going to equal x squared, and x will equal the square root of 5 times 10 to the minus 13. And that equals 7.1 times 10 to the minus 7. Moles per liter. That's how much silver bromide will dissolve. Now in part B and part C, it's the same reaction with the same KSP, but now there is a common ion waiting for us. So parts B and C of this are common ion problems. And when we have a common ion problem, we have to use the ICE table. So my two ions are Ag plus and Br minus. ICE, initial change and equilibrium. Initially, this is in 3.0 times 10 to the minus 2 molar silver nitrate. That means there's going to be silver ions waiting for us. And because every single silver nitrate that divides up is going to give me one silver, I'm going to have the same concentration. So initially, I will have 3.0 times 10 to the minus 2 of silver, and I will have 0 bromide because I have not dropped the salt in yet. When I drop the silver bromide salt in, they will both increase by some amount which we call x. So at equilibrium, I would have 3.0 times 10 to the minus 2 plus x and x. And I get to ignore the tiny little bit of x that shows up. 3.0 times 10 to the minus 2 is much, much bigger than this x, so I can disregard it. Once I know these numbers, I can just put them into the equation. So we already know it's 5 times 10 to the minus 13, and that equals the concentration of silver, which is 3.0 times 10 to the minus 2 times x. So x equals the KSP value divided by the silver, 3 times 10 to the negative 3, and that turns out to be 1.7 times 10 to the minus 11. Moles per liter of silver bromide. A quick comparison, we see that the solubility is much smaller with a common ion present, and that's the way it should be. Part C is another common ion problem, except this time it's the bromide ion that is waiting for us. So my initial silver is 0 because I haven't dropped the salt in yet. Bromide is 0.1. Still be plus x for each after I drop the salt in, resulting in silver with a concentration of x and bromide ion because I get to ignore that plus X, is going to have a concentration of 0.1. So, just like the other one, 5 times 10 to the minus 13, our KSP is going to equal X times 0.10. X is going to equal the KSP divided by the concentration of bromide. And in this case, X equals 5 times 10 to the minus 12. Moles per liter of silver bromide.